Hey guys, Mr. Backerberg here. In this video we're going to look at two major theorems from algebra. So the first major theorem that we're going to take a look at is the fundamental theorem of algebra. And the fundamental theorem of algebra says that if you're dealing with a polynomial function of degree n, then it's going to have n complex zeros. Some of those zeros might be real, some of those zeros might be non-real, but the number of zeros will always match up with the degree of your function. Now some of those zeros could be repeated, but you would still end up with n zeros for an nth degree polynomial. So if you're thinking about a quadratic function with a degree of 2, that has to have two complex zeros. They might be real, they might be imaginary, but it still has to have two zeros. Or a cubic function, that has to have 3 zeros. A quintic function, which would mean a power of 5, would have to have 5 zeros to it because its degree is 5. The next big theorem that we're going to take a look at is the linear factorization theorem. So if we're looking at f of x being a polynomial function of degree n that's greater than 0, then our f of x function has to have precisely n linear factors. So whatever the degree of our polynomial is will match up with the number of linear factors that our polynomial will have. And our function f of x can be written in this factored out form with a leading coefficient of a and then having our complex zeros represented by those z values in there, so x minus z1 and x minus z2. Now those z values aren't necessarily distinct numbers, some of them might repeat themselves along the way. Now if we're dealing with real number zeros, then those can be represented on the graph of a function as x-intercepts, but if we're dealing with non-real zeros, so imaginary zeros, those won't be x-intercepts for the graph of a function. So in this first example, what we've got is a polynomial function written out in its factored form, but we want to do a couple different things with it. We want to write it in its standard form. We also want to identify the zeros for the function and the x-intercepts for the graph. Now I'm going to do things a little bit out of order on this one, and I'm actually going to find the zeros of this function first. Since I've got my function written out in factored form, then to find the zeros, what I want to do is I want to take all of those factors and set them equal to 0 so that I can solve. So I'm going to take the x minus 2i and set it equal to 0, and I'm also going to take the x plus 2i and set that equal to 0. So in this first one, I'm going to have to add the 2i over to the other side, so I'm going to get a 0 at x equals 2i. And on my other one, I'll have to subtract the 2i over to the right-hand side, so I'll get a 0 at negative 2i as well. Now, as far as thinking about the x-intercepts of this graph, I know that I have imaginary zeros because we have those i's in there. And if you're dealing with imaginary zeros, then those will not be x-intercepts for the graph. So because we're getting imaginary zeros, this graph doesn't actually have any x-intercepts. Now what we're going to do is work on taking this factored out version of the polynomial and writing it in standard form. So as I'm looking at this, we're basically multiplying two binomials together. So I'm going to just start foiling this out. So I'm going to take the x times the x to get x squared. I'm going to take the x times the positive 2i to get plus 2ix. Then I'm going to take my negative 2i times x to get minus 2ix. And then I'm going to take my negative 2i times my positive 2i to get negative 4i squared. Now as I'm looking at this foiled out version of my polynomial, I see that I've got a plus 2ix and a minus 2ix. So those are going to cancel each other out. Now on the back end, I can see that we have I squared. And thinking back to some stuff with imaginary numbers, I squared is the same as negative 1. So if we take negative 4 times this negative 1 on the back end, then that's going to turn into a plus 4 with our x squared. So this factored out version of our polynomial can actually be written just as x squared plus 4. Looking at another example, doing the same thing, so we're given a factored out polynomial and we want to write it in standard form identify the zeros, and identify the x-intercepts. So I'm going to start with the zeros again. So what I'm going to do is take all of my factors and set them equal to 0. So I take the x minus 5, set that equal to 0. So I'm going to get x equals 5 as a 0. Then I'm going to take the x minus root 2i and set that equal to 0. So I'm going to get x equals positive root 2i as a 0. And then if I take the x plus root 2i and set that equal to 0, then that'll give me a 0 at x equals negative root 2i. Now in here, as far as finding the x-intercepts, the only real 0 that we have in there is the 5, meaning that we're going to have an x-intercept at 5, but the other zeros are imaginary, meaning that those ones will not be x-intercepts. Now I'm going to start writing this polynomial in standard form. Because we've got 3 factors, this one is going to end up being a cubic function. I'm going to look at those 2 binomials on the far right hand side with those imaginary numbers, and I'm going to start there with my foiling. So I'm going to take the x times the x on the end, so we'll get x squared. And then I'll take the x times the positive root 2i, so I'm going to get plus root 2ix. Then I'm going to take my negative root 2i times that x, so I'm going to get minus root 2ix. And then if I take the negative root 2i times the positive root 2i, now since one of them's positive and one of them's negative, we're going to get negative. Now if we take root 2 times root 2, that's going to be the square root of 4, but the square root of 4 is just 2. And then if I take the I times the I, that's going to turn into I squared. Now again, I should notice that these middle 2 terms are going to cancel each other out. And I've got this I squared on the back end, so that I squared really is the same as negative 1. So if we take negative 2 times our negative 1, then those back end factors multiplied together are going to give us x squared plus 2. But we have to remember that we still have that x minus 5 factor hanging out in the front that we haven't used yet. So I'm going to have to do a little bit more foiling. So I'm going to take the x times the x squared to get x cubed. Then if I take the x times the 2, I'll get plus 2x. The negative 5 times the x squared is minus 5x squared. And then negative 5 times 2 is negative 10. Now I'm not quite in standard form yet because typically we like to write our functions in power descending order. So going from highest power down to lowest power. So I'm going to rearrange this a little bit to say x cubed minus 5x squared plus 2x minus 10 as my standard form cubic polynomial. That's going to be it for this video. Thanks for watching.